Hey, 5th grade mathematicians. Today we're going to do entry task day 129. Problem number 1. Enter 1,000 as a power of 10. So we know, remembering way back to September, we know that 1,000 is equal to 10 times 10 times 10. And to write that as a power of 10 would be 10 to the third power, because 10 is a factor 3 times. And it is the only factor. So, next problem. John has 39 cups of dog food. He pours an equal number of dog food into 8 dishes. Enter the number of cups of dog food in each dish. So again, we're going to demonstrate this using a tape diagram. And that's going to represent our whole. And John starts out with 39 cups of dog food. And we're going to divide those 39 cups into amongst 8 dishes, dog dishes. And we want to know how much is in each one. So we're going to set up our problem. We are dividing 39 by 8. I'm going to do it as a fraction because I know my 8's multiplications, and I know that 4 eighths is 32, 5 eighths is 40, so I'm going to have 4 eighths, and then there's going to be 7 out of 8 left over. So it'd be 4 and 7/8 cups would go in each dog dish. 4 and 7/8 cups of dog food in each dish. Okay, problem number 3. 3 children share 1/4 pounds of chocolate equally. Enter the amount of chocolate in pounds each child receives. So again, let's start out with our whole. And in this case, this would be 1 pound of chocolate, but the children share 1/4 of a pound. So they probably bought a 1 pound, I'm going to erase that part there. They probably bought a 1 pound candy bar, ate some of it, and now there's a 1/4 pound left that they need to share amongst 3 kids, right? So we want to know how many 1/3s are there in the whole pound. So basically, what I like to think of, though, is I take this 1/4, and I'm looking to find out what is 1/4 divided by 1/3, or what is 1/3 of 1/4. And that just takes us to our understanding of multiplying fractions. 1/3 of 1/4 is 1/12. And you can see that there are 12 little green sections in the candy bar. So each child would get 1/12 of the chocolate. Okay. Let's move on to problem number 4. The line plot shows the distance in kilometers that 8 students swam last Saturday. Enter the total distance in kilometers these students swam last Saturday. So the first thing that I want to do when we look at this line plot is we have to determine what our intervals are. So let's zoom in here. We also notice about this line plot is it doesn't start at 1. It just shows the first whole number is 3, right? And the last whole number it shows is 5. And that's because all of the data falls between 3 and 5. So let's look between 3 and 4 to see what our intervals are. So we have 1, 2, 3, 4. So there are fourths, okay? And I just want to confirm between 4 and 5. 1, 2, 3, 4. So, yep. So we're looking at fourths on the line plot. And the first thing, because I'm finding the total, I'm going to write out my expression. So this data point right here is 3.5 or 3 2/4. I'm going to write it in fourths because when I add all these up, I don't have to find a common denominator. So I have 3 copies of 3 2/4. And then I'm going to add it to 1 copy of 3 3/4. I might run out of room here and have to go on to the other line. I'm going to add it to 1 copy of 4 1/4. I have 2 copies of 4 2/4. And I'm having some issues with my multiplication sign. 2 copies of 4 2/4. And then my last data item is I have 1 copy of 4 3/4. So now I'm going to combine all those together. So I'm going to simplify what's in parentheses. And 3 times 3 is 9, and 3 times 2/4 is 6/4. Or I have 9, well, I'll just write 9 6/4. And then I'm going to do 2 copies. 2 times 4 is 8, and 2 times 2/4 is 4/4, which is 1 whole, so that would be 8 plus 1 is 9. And then from here, I'm looking for things that go together. But I'll add there are a few different ways that I can do this. I'm looking at this, and I'm saying, okay, 3/4 and 1/4 is 1 whole, right? So I'll add 1. And then I have 3 plus 4 is 7. And did I not write the 1 down? Where did that go? 1. And then I have 3 plus 4 is 7. And 4 plus 3/4. So it really doesn't matter how you simplify it. You know, I just look for things that go together. You may think of adding up all the whole numbers first and all the fractional parts, and you can do that. I'm going to, at this point, add my whole numbers. I see that that equals 10, right? So 9 and 10 is 19, and 7 is 26, and then 26 plus 4 is 30. So when I add up all my whole numbers, I have 30. And then I'm going to add my fractional parts, and I have 6/4 and 3/4, which is 9/4, which is the same as 30 plus 2 and 1/4, which is equal to 32 and 1/4. So one of the things that we can take away from this, and the more we work with numbers, the more we're able to do mental math and recognize relationships with the different numbers. And you guys are getting really good at that. You're soon to be middle schoolers, and you know, as I've mentioned this before when I'm doing my videos, as I'm doing these, you might be looking at that and saying, well, I would do it a different way, or I see a different relationship. And that is a really cool thing about numbers. As long as we're following the laws of math, there are often more ways to arrive at a correct conclusion. So that's what one of the fun things about math is. Okay, let's take a look at problem number 5. Patterns P and Q are generated using these rules. Pattern P, start with 2 and add 4. Pattern Q, start with 1 and add 2. And then we're asked the question, which set of ordered pairs is generated from corresponding terms of pattern P and Q? So let's go ahead and I'm going to enlarge this a little bit, and we're going to start with 2 and add 4. So we start with 2. 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. And 14 plus 4 is 18. I'm going to stop there. And then the next pattern, we start with 1, and we're adding 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. And 7 plus 2 is 9. So patterns P and Q. So let's look at our corresponding terms, because they don't have all of them. So I see that this is 2 and 1, and that's 2 and 1. So I'm going to eliminate 0, 0, because that's not an ordered pair for either of those. And let's look at our next one. We have 6 and 3, and then 10 and 5. So we would be looking at C as the corresponding pattern. Now, what's interesting about this one is we have patterns P and Q. And a lot of times what we have been doing is they'll say pattern X and pattern Y. So they don't always use X and Y, but we usually follow alphabetically. So P comes first in the alphabet before Q. So in our ordered pair, we would then have 2 and 1, 6 and 3, 10 and 5. So there you have it. We have day 129, and we only have 4 more days in this school year. Crazy to think about.